Okay, today we're going to be going over radicals and rational exponents. So we just had to go over this one example, though you probably may already know how to do it if you already know how to do the factor trees. So when we simplify the fourth root of 128 and to the seventh, do your factor tree. 2 in 64, 2 in 8, no, sorry, 2 in 32, 2 and 16, 2 and 8, 2 and 4, 2 and 2. I could have done it differently. I just chose to keep using 2's. And to the seventh means n 7 times. Okay. Now because of the index being 4, we want to circle groups of 4 of the same thing. So I see 4 2's and 4 n's. So to the outside, I move 2n. The fourth root of, what do I have left? Well, 2 times 2 times 2, which is 8. N, and to the third. So that's it for simplifying higher indexed radicals there. Today, though, our focus is on rational exponents. A radical can be rewritten as a fractional or rational exponent. So the nth root of a can be written as a to the 1/nth, or the square root of a can be written as a to the 1/2, because the index is 2. The cubed root of a can be written as a to the 1/3, because the index is 3. Now, if the stuff is also being raised to the power, you can kind of rewrite it in multiple forms, which can make this a little confusing. But if you have an exponent on the outside or an exponent on the inside, then they can be written as a to the power of the exponent over the index. So if we look at some examples, so we're going to write each in exponential form. So we have our index of 2. The 5 has an exponent as well. So we can rewrite it as 5 to the exponent over index. So 5 to the 3/2. Go into the second one. I'm going to rewrite it. Notice there's more than one thing on the inside of the radical here. So I'm going to have that in parentheses. The exponent, or the shared exponent at least, is 7 over the index is 3. And silly me, I completely forgot to write the stuff that was on the inside. So 5x to the third. Now you can also simplify this in other ways, but the goal of these particular examples is just to switch the form. So that's all we're going to do for this example. Now sometimes in SOL questions, if you know something is a perfect exponent, like a perfect square, a perfect cubed, a perfect fourth power, and so on, you may want to start by just rewriting it as a number to a power. So I know that 16 can be written as 4 squared, or 2 to the 4th power. If I factor it down to prime numbers, you would see that 2 to the 4th power. So oftentimes you won't see this written as 16 to the 1/3. You probably wouldn't see that as an SOL choice. Instead, they would convert it to 2 to the power of 4, because that's what 16 is. And then they would take this and convert it to the fractional exponent, writing it as 2 to the power of 4/3, with the exponent on top, index on the bottom. Okay, and is there another one on this page? Nope. Okay, this time we're going into radical form. Again, we're just switching the form. We're not actually simplifying this time. So switching the form here. So it's 5 to the 3 over 4. Top number is an exponent. Bottom number is an index. So I could write it as the fourth root of 5 to the 3rd. Or you could write it as the fourth root of 5 all raised to the 3rd. Either way is correct. Number B, notice how they already have a shared index. So oftentimes when we rewrite this as a radical, we would rewrite it with the shared index. Again, the bottom number is the index. And then individually, it would be x to the third, y to the 36. So that's one way to rewrite this particular problem. Because they don't have a shared exponent as well, I can't just write it in parentheses with an exponent out here. Can't do that because they don't have the same exponent. Index I can though, so I wrote it as a single radical. The last one in this group of problems has a negative exponent. Before I can switch the form, I gotta deal with the negative exponent. If you recall from Algebra 1, that means move it to the opposite part of the fraction. So I'm going to rewrite it as 1 over 5x to the positive 3/2. And then I'll switch the form. Top number's an exponent, bottom number's an index. So it's 1 over the square root of 5x to the third, or you can also write it as 1 over the square root of 5x to the third. Those two are equivalent. It doesn't really matter which way you look at it. Sometimes one way is better than, more useful than the other way. Okay. Now, for example 4, we're going to actually simplify the expression. So, in order to do this, there's a number of ways you can approach it, which can be a little weird. Personally, when I deal with fractional exponents, I like to try to rewrite any numbers I have as something to a power. As I discussed earlier, 16 can be written as 2 to the power of 4. A squared and 3/4. From here, I guess I might distribute my exponent using exponent properties, give my exponent to each. So it becomes 2 to the power of, 4 times 3/4 would just be 3. And 2 times 3/4 would be a to the power of 6/4, which reduces to 3/2. If I rewrite this, you may see answers written as 8. 2 to the third power is 8. A to the 3/2. They may switch it back to radical form. So they may write it as 8 times A, not times A, times the square root of A to the third, which can be written as, grouping my groups of 2, which can also be written as 8a square roots of a. So it really just depends. This is acceptable if you're just simplifying it. This is also acceptable. The other version here, you wouldn't leave it like this if you're asked to simplify because it's a to the third on the inside. So either the two in the box are fine. Today, as you do classwork and stuff, please try to get to the answer it has on the answer key. That will help you for SOL and benchmark purposes. And SAT purposes, I guess. Last one here is a multiple choice question. So you notice, again, we have a number. And now normally I might try to do my factor tree and stuff. However, if I take a second to look at the answer choices, you can see that they're fractional exponents. Anytime I'm dealing with fractional exponents, instead of just trying to do my factor tree, I try to write my numbers as something to a power. So 49 is a perfect square. It's actually 7 to the power of 2. So I would start by rewriting this particular problem as 7 squared a b to the third. Then I would switch everything to a fractional exponent. That means I'd rewrite the cubed root as a 1/3 exponent, which I can then give to each individual base. So 7 to the power of, 2 times 1/3 is 2/3. A to the power of, 1/3 And b to the power of 3 times 1/3 is just 1. If you look through the answer choices, it looks like answer choice C is the best bet. It's the only one with that. And that's it for today. Again, try to get to the answers on the classwork. Try to make sure you're checking your answers and trying to get to them. If you get stuck, ask for help from either me or your neighbors.